Welcome to David Alexander Maths Tuition. This is chapter 5D on sector area. Okay, so let's put it into practice. The formula is 1/2 theta r squared. So 0.5 multiplied by theta, which is 0.5, multiplied by 12 squared. So the area is 36 square centimetres. Let's take a look at another example. So the shaded area is obviously the blue bit. So if this is pi over 4, then the rest is going to be 2 pi minus 1 pi over 4. So 2 pi in terms of quarters, that is 8/4 pi. So therefore, if it's 8/4, take away 1/4, then this is 7 pi over 4. So 1/2 theta r squared, so that's 7 pi over 4 multiplied by 1/2 multiplied by 16 squared. So let's just whack that into the calculator and multiply by 7 pi over 4, and we are getting 224 pi in terms of pi, or 703.7 square centimetres, correct to one decimal place. Okay, so in this question we're working out the shaded area, which is a segment. Now the best way to do, well, probably the only way you can do it, is work out the area of the sector and subtract the area of this triangle. Now we know that the area of a sector is 1/2 theta r squared minus the area of this triangle, which is 1/2 AB sine C. Well, we'll keep it in terms of theta, so 1/2 AB sine theta. Now A and B are both, in this case they're both 13, but the key thing is that both A and B are radii. So what we have is, I'll write it over here, 1/2 theta r squared, take away 1/2 r squared sine theta. And what we can do is factor out the 1/2 r squared, theta minus sine theta. So this is a formula we can use for the area of a segment. Now, of course, you don't need to remember the formula for the area of a segment. You can just work out the area of a sector, which I know you can do, and subtract the area of a triangle without having to worry about it. This is just a way of tidying up the formula a little bit. So what we have is 1/2 multiplied by 13 squared, 1.1 minus sine 1.1. Again, just make sure your calculator is in radians. So 0.5 multiplied by 13 squared, open brackets, 1.1, take away the sine of 1.1, and what do we get? We get 17.64, that is square centimetres, and that is to 2 decimal places. Okay, so here what we're trying to do is we are working backwards, so it shouldn't be too difficult. We know that 1/2 theta r squared is the formula for the area of a sector, and we know the area of the sector is 53. So usually what I do whenever I've got a formula with a half in, I just double the answer, so that's going to be 106. So r squared is going to be 106 over 1.3, and 106 divided by 1.3 is 81.5, so therefore r is going to be the square root of that, so r is 9.03 centimetres, and that's just to 2 decimal places. Okay, here's another example. We know that 1/2 theta r squared will be 47 pi, so therefore theta r squared is going to be 94 pi. And we know that theta is, okay, the shaded area is this part here, so that's going to be 15, no, it's going to be not 15 pi over 16, what am I talking about? It's going to be 31 pi over 16, because the whole thing would be 2 pi, which is 32 sixteenths pi, so take away that 1 pi over 16 gives us the 31 pi over 16. So 31 pi over 16, lots of r squared, is 94 pi. I'm just going to make things simple by just dividing through by pi. So therefore r squared is going to be 94 multiplied by 16 over 31. So 94 multiplied by 16 divided by 31 is 48.5-ish. Square root it, because this is r squared, so r is 6 1.96 centimetres, again just rounding to 2 decimal places there. Okay, here's another one. So we know that half theta r squared is 124, so theta r squared is 228. So all we're doing is simply doing 228 divided by 15 squared, so 228 divided by 15 squared, and we are getting our theta, or our x, as 1.013 recurring radians. Okay, here's another example. So the chord AB of a circle, centre O and radius 8, has length 12 centimetres and subtends an angle of x radians at O. Let's just draw that out. Okay, so here is my chord AB, here's my angle x, centre is O, and the radius is 8. So OA is 8, OB is 8, and AB we know is 12. We need to show that the cos of x is negative 0.125. Okay, so we know the cosine rule is a squared equals b squared plus c squared, take away 2bc cos a, or we can just rearrange this as b squared plus c squared minus a squared over 2bc is the cos of a. So presumably 8 squared plus 8 squared, take away 12 squared over 2 times by 8 times by 8 will come to negative 0.125, we shall see. So I'll set up a fraction on my calculator. So 8 squared plus 8 squared, take away 12 squared over 2 times 8 times 8, and is negative 0.125. There we go. I've shown that the cos of x is negative 0.125. Done. Okay, so you want to find the area of this, the minor sector AOB. So it's the sector, not the segments. So let's just work that out. So that is a 1/2 theta r squared. So that's 1/2. So we don't know what theta is, but we know that the cos of theta is negative 0.125. And we are in radians, so inverse cos that answer, I'm getting 1.69 or 1.70 to 2 decimal places. I'll just put 1696. Well, I'm just going to just use my ANS button anyway. Okay, so I'm going to multiply that number that's on my calculator by 1/2, in other words divided by 2, and then multiply it by 8 squared, or 64, and therefore I've shown that the minor sector area AOB, that is 54.28 square centimetres, and that's to 2 decimal places. So just be careful here. The minor sector is the whole sector here, so basically it's all of this, as opposed to the sort of Pac-Man's head on the other side. The area of a sector of a circle of radius 16 centimetres is 180 square centimetres. Find the perimeter. Okay, so what I'm going to do is just do a little diagram to help me here. So here is my sector, the white bit. So the radius is 16, and we have 180 as the area. So in order to work out the perimeter, well, the perimeter is going to be quite easy. It's just going to be 16 plus 16 plus the arc length here, which we'll call L. Now I know the arc length is our angle, which we'll call theta, multiplied by 16. So I need to work out what theta is. So I'm going to work backwards from the area. So the area is 1 theta r squared equals 180. So therefore theta r squared is 360. So therefore theta is 360 divided by 16 squared. So theta is 360 divided by 256, which is 1.40625. Okay, so the arc length is going to be 1.40625 multiplied by 16. So the arc length is 22.5. So therefore the perimeter is going to be 16 plus 16 plus the 22.5. And that is 54.5 centimetres. And we are done there. Okay, so this is similar to a question in the book. The first thing we need to do is show that the angle BAC is 1.50 so BAC, this angle here. So I'm going to use the cosine rule. AB is 18, BC is 22, and AC is 14. So we just need to show that we're getting 1.5 here. So that's going to be 18 squared plus 14 squared, take away 22 squared, divided by 18 times by 14 times by 2. So that's just my rearrangement of the cosine rule there. So that's going to be the cos of BAC. So the cos of BAC is B squared plus C squared minus A squared over 2 times B times by C. Right, so let's set this up on the calculator. 18 squared plus 14 squared, take away 22 squared over 18 times 14 times 2. So the cos of BAC is 1 over, let me just write that down. So cos BAC is 1 over 14. So therefore BAC is the inverse cos of that. So shift cos my answer. I'm getting 1.499, which is 1.50 to 3 significant figures. There we go. That is the first part done. Okay, so for part 2 of this question, we're working at the area of the flower bed, which is the brown bit. So I'm going to do this by working out the area of the triangle ABC, take away the area of the sector. So the area of a triangle is 1/2 AB sine C, or 1/2 AB sine theta in this case. Take away the area of the sector, which is 1/2 theta r squared. Okay, so that's 1/2 multiplied by A and B. Remember, A and B are, A is going to be 8 plus 10, which is 18, and B is 8 plus 6, which is 14, or the other way around, it doesn't matter which is A, which is B, multiplied by the sine of 1.50, or 1.5, take away 1/2 times 1.5 times r squared, so times 8 squared. There we go. So grab the calculator, 0.5 times 18 times 14 multiplied by the sine of 1.5, subtract 0.5 times 1.5 times, I'll just put in 64 there, and we are getting our answer, which is 77.68 square meters. And okay, that's to 2 decimal places. There we go. So that is the area of the flower bed. So a lot of it's just problem solving. Sometimes we're going to be using the cosine rule and the sine rule as well. There we go. So not too bad.